What is the role of the coefficient a in a quadratic function? The coefficient a determines the shape of the graph of the quadratic function, like this. When the absolute value of a increases, the graph becomes narrower. When the absolute value of a decreases, the graph becomes wider. Before you start, you need to recall that the absolute value of a number is its positive value. So the absolute value of a positive number is the number itself. For example, the absolute value of 5 is 5. The absolute value of a negative number is its positive counterpart. So the absolute value of -5 is also 5. Remember that we denote absolute value by placing vertical bars around the number. Now, let's look at the graph of a quadratic function. Remember that a quadratic function is in the form f of x equals ax squared plus bx plus c. To start your journey, choose the simplest quadratic function there is, namely f of x equals x squared. Here, a is equal to 1, while b and c equal 0. This function is great for studying the role of the coefficient a. Let's first see what happens to the shape of the graph when a is positive, and then what happens when a is negative. Let's check out what happens when you change the value of a. When a is positive, increasing the value of a would increase the absolute value of a. Remember, it's already equal to 1. This slider shows the current value of a. Let's increase a to 2, then to 3, and so on. Notice how the graph's U-shape gets narrower and narrower. So, when a is positive, increasing its value makes the shape of the parabola, the U, narrower. Now, set the value of a equal to 1 again. This time, let's decrease the value of a. Remember that the absolute value of a will also decrease in this case. So you start decreasing the value to 0.9, then 0.8, and so on. Notice how the shape of the parabola gets wider and wider. So, when a is positive and its value is decreased, the U-shape of the graph gets wider. It's important to remember that in a quadratic function, the coefficient a can't ever be equal to 0. Then you wouldn't have a quadratic function or a parabola anymore, because there would be no second-degree term. It would be a linear function. Okay, now let's move on to see what happens when a is negative. Set a equal to -1 so that f of x is minus x squared. Because a is now negative, that means decreasing a would increase the absolute value of a. Let's take a moment to study this. The absolute value of -1 is 1. The absolute value of -2 is 2, and so on. This pattern continues forever. Let a decrease to -2, then -3, and keep going. Note how the graph's U-shape gets narrower and narrower. So, when a is negative, decreasing the value makes the shape of the parabola, the U, narrower. So again, as long as the absolute value increases, the graph will get narrower. Let's reset a to -1 and see what happens if you increase a. That means that the absolute value of a will decrease. You set a to -0.9, then -0.8, and so on. notice how the shape of the parabola becomes wider and wider. So, when a is negative, increasing the value of a makes the u-shape of the graph wider. It becomes wider because the absolute value of a decreases. Again, a can't be equal to 0 because then you won't have a quadratic function at all. The coefficient a determines the shape of the graph of a quadratic function, like this. When the absolute value of a increases, the graph becomes narrower. When the absolute value of a decreases, the graph becomes wider.